Okay, hi everyone. So today we're going to solve this problem that is yeah. So that is 62 problem of LeetCode and the name is unique paths. It's a medium level problem, a pretty famous problem. Let's see. So there is a robot. Okay, we can visualize this better by having a diagram. So there is a robot on a m cross n grid. Okay, so this is a grid and this grid is m cross n, right? The robot is initially located at the top left corner of the grid, that is 0, 0 cell. So for example, these cells are noted as 0, 1, 2, 3, and then 1, 2, 3, right? So if these cells are, so if a robot is initially, no, sorry, it doesn't has to be like this. It has to be 0, 1, and 2. So if a robot is standing on the initial cell, that is the 0, 0 of the grid, then it has to find its own ways, or maybe there could be multiple ways to reach a finish position, and that finish position would be m minus 1 n minus 1, right? Because this is going to be m minus 1 n minus 1. By that I mean 6 comma 2, right? And according to the given problem, we are given m as 7 and n as 3. So it's going to be the last cell is going to be of the grid according to our notation that it's a 0 comma grid. Then it's going to be m minus 1 and n minus 1, it's given as well, right? Now we need to, the robot can only move, this is the very important line, that the robot can only move in either in down or right at any point in time. So if a robot is standing on this cell, then it can move in the right direction or in downwards direction. It cannot move in upwards or left direction. That is the main thing. So for example, if a robot is standing on this place, for example, a robot is standing at this place, then it can move in downward direction, that is known to us, but it cannot move in the right direction, because right direction will be out of the boundary for the grid, and that should not be the case, right? Similarly, if the robot is at this cell, then it can move in the right direction, but it cannot move in the down direction, because that will be an out of boundary case for the grid, and we don't want that. That is why these cells will only have one way of reaching to the other cell, that is the right direction, and for these cells it will only have downward choice. Now we are given two integers, that is m and n. Return the number of possible unique paths that the robot can take to reach a bottom right corner. Okay, so we asked this question to this robot, and robot said that it's very easy. Let me show you. And the path that he have calculated is, so he said that I will go for this path and then this path. This is one, right? This and this is second path. Great. Then from this path to this part, and then okay, third, and then from this path to again the same route, and then this is going to be fourth. And then he realized after uh 5 and 6 calculation of unique paths, he realized that there can be multiple paths based on the number of cells we have in the grid. There can be multiple paths. That is why he said us to calculate the answer and tell me how many unique paths are there. So let's see how we can do this. So we are at, initially we are at 0 comma 0 cell, right? From 0 comma 0 we can either, you know what, it will be better if I can show you the diagram. Yeah, okay. So we are initially at 0 comma 0 cell, and we can, go either in this direction or in this direction. Let's say we went to the right, then we will be at, from 0 comma 0 we will be at 0 0 comma 1 cell, right? And if we intend to go to the downwards direction, then we will be at 1 comma 0 part, 1 comma 0 cell. And from this cell we have a choice. This is the cell, and we again have a choice that we can go to the right direction, that is this cell. So this cell is going to be 0 comma 2, or we can go to the downwards direction, that is 1 comma 1. And from this cell we have a right choice that we can go, um, that is the 1 comma 0 cell, we can go to the right direction, that is 1 comma 1, or we can also go to the downward direction, that is 2 comma 0, right? So now, after analyzing that how a procedure is and how things will be calculated, you can see that this is more like a recursive tree, and this is a problem of recursion. But the constraints are so heavy, and there are some overlapping problems in your recursive tree, because if you can see that, yeah, so this is 1 comma 0, 1 comma 1, and this is 1 comma 1 again. This 1 comma 1 will be calculated in its own subtree, and this 1 comma 1 will be calculated in its own subtree. Why shouldn't I, when I was calculating this 1 comma 1, should I store this 1 comma 1 into this dp of 1 comma 1 and have some value x, so that when I'm calculating this one, then I don't have to recalculate all the values for 1 comma 1. I can just simply take this value from this cached array of dp, and now I will simply have x, and no calculations would be performed. So calculations will only be performed each time. That is why this optimization of recursion make this problem a very standard concept of dynamic programming, and we will go to that. But first of all, let's see how we can solve it with recursion. So this is a recursive code. So first of all, I will be choosing a function, and for this I'll be choosing solve, and I am initially at the index. So this is like a like a bottom up technique where I am having the values, not a bottom up, I think it's a top down technique, because the base case will be, yeah, because the base case will be the zero values, and values will be extracted from the base case, and then they'll be given to the bottom values on the backtrack part. So the solve function, I have some faith on this function that this is going to return me ways or unique ways, unique ways at m minus 1 and n minus 1 cell, or ith or jth cell, right? Ith or jth cell. That is why we have this function with I, j. So we will be returning the number of unique ways we have at this cell, that is I comma j. And then we have a vector of dp for memoization, and then we have int m and n. M and n are used because we want to denote how many, actually we don't really need to use m and n. We can like drop this whole concept of using m and n. We don't need that. Yeah, yeah, I just realized that we don't need to use m and n. So we cannot, so we can just like erase them from the here, and okay. Yeah, so now so my first step is, these are the base conditions, and I will come back to them, but not now. First, let's see how our induction is working. So this is the base case, and base case is actually these, all of, not all of them. Yeah, this one. This one is the base case. This one is memoization, and this is induction. Let's see. So I say that dp of I comma j will be dependent on the previous cell, right? If you will remember this diagram, if we are, let's say, Yeah. So let's say I'm on this cell and I want to calculate the number of ways of reaching this cell. Then this cell will be dependent on the cell that it has, that the associated cell which has a destination of reaching the current cell, right? Which means the I minus 1 cell. And this cell and the number of ways of reaching this cell will tell me how many ways are there for this one exactly. And for this one will be 1 because the start will have its own one way. And for example, we have this cell. Now this cell will be dependent on the number of ways of reaching this cell and this cell. So let's say if there are x and y, then the total number of ways for this particular cell will be x plus y, right? This is like a basic observation from the question, that number of ways will be dependent like this on each other. Now the code part. Yeah. So now I will say that dp of I minus 1, that is the cell that is I minus 1, right? Yeah, the cell that is just one above the current cell. And j minus 1, the cell which is on the left of the current cell. So for example, this is a matrix and this is a cell that I'm counting the number of ways of reaching this cell. Then this cell will be dependent on this one, and this cell will be I minus 1 comma j, and this cell as well, this will, and this cell will be, sorry, this cell will be I comma just a second guys, so this cell will be I comma j minus 1, and this cell will be I minus 1 j, right? Yeah, that is why we are now going to calculate the solve function is going to give me the number of ways for I minus 1 comma j cell, and another solve function is going to give me a value for the number of ways for I comma j minus 1 cell. And after analyzing them, after having these values, we will be storing them in the dp, caching them in the dp 2D vector, and we'll be returning that value. So this is our induction part. Now let's see the base case. Now let's see the memoization. The memoization is simple. If the dp value, so I have initialized the dp value with -1, and if a value introduced to, if a value introduced in the dp of I comma j cell is not -1, then it certainly means that we have processed that particular cell and we have found the number of ways for that cell. And if there are number of ways for that cell, we don't want to overlap things and again calculate all of the calculation for the cell which we have already done and stored. So we'll be using that cell again, using that information again, right? And now the base case is if I is equal to 0 or j is equal to 0, we'll be returning 1. And why it is that? Because if you will look closely, then because if you will look closely, then you can see that the number of ways of reaching this cell will be 1. Why? Because there is only one way of reaching this cell, that is from the start. The number of ways of reaching this cell will also be 1 because it can only be reached from this cell. And similarly for these cells, the number of ways will be 1. I'm sorry. And the number of ways of reaching this cell will also be 1 because it can only be reached from the start. And the number of ways of reaching this cell will also be 1. So by this concept, I can say that the number of ways of reaching the cell which has I0 and J0 will be 1. And if it is 1, that is our initialization, that is the base case in our recursion. And these values will be used to solve for the induction part. So this is the base case and we'll be returning 1, and similarly we will have our answer. Now if we want to analyze the time complexity of this one, the time complexity will be as obvious because it's a recursive problem and we are memoizing it. It would be linear, but not, and by linear I means the number of cells, but it's not that simple because it's a recursive thing, and even after memoization there's still some high chance that in worst case it can be exponential, right? So in order to avoid this problem, we have a very sleek solution, a very fast one, and that is tabulation method of dynamic programming. And in this case I'm initializing the dp vector with 1. Why 1? Because I want my, the ith row, the 0th row and jth column to be 1. Why shouldn't I initialize the whole vector with 1, right? This will be more beneficial to me. And then I'm going to calculate the dp of I comma j, which is dependent on the cell that is I minus 1. That is the cell that is above the current cell, and dp of I comma j minus 1, that is the cell on the left of the current cell. So this cell is going to be dependent on this one, that is I minus 1 comma j, and this cell is also going to be dependent on this cell, that is I comma j minus 1, right? So after having these values, it's going to give me, and I'll be storing, like this is like for I comma j, I'm storing the values for I comma j unique ways they have. In this part I'll be storing for each cell the unique ways it can have, and finally we want to know how many ways are there to reach the finish point, and that finish point is located at m minus 1 and m minus 1. That is why we are returning dp of m minus 1 and n minus 1 as our answer. So this is the problem, and the time complexity for this one will be order of n, where n is the number of cells, and to be more precise you can say that it's order of m cross n, right? And this is even in the worst case, even in the best case or average case, this is going to be m cross n. That is why it's a good solution. And this is the time complexity, and space complexity is also going to be m cross n because we are using a dp vector. And similarly for the recursive part as well, the space complexity will be, auxiliary space complexity will be m cross n. Even the overall space complexity will also be n cross n, because we are only given two variables and they are constant in space, but using a using a vector is going to be a costly process in the space part. But on the time part, it's a very optimized problem, and you can also check this solution in the description, the source code, and if you want to try the problem yourself, you can also try the problem by the link in the description. So thank you guys for watching. Have a good day.